The CPU is going to address the data from the computer memory by referring the memory address. So what is a paging? Here paging is nothing but the main memory of a computer system will be divided into number of pages, and each pages will be having fixed length of frames. Each process will be divided into number of pages, and number of pages in turn it will be having a collection of fixed number of frames. Dear students, welcome to B.Ca classes. I am Ravi Kumar K.R., lecturer in computer science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start our session with the concept that is virtual memory. Students, in this session, we are going to cover the topics virtual memory, paging, demand paging, and thrashing. So let us start with the definition of virtual memory. See, what is virtual memory? Now we know what is a memory. Memory is a basic unit of computer's storage in computer system. And there are two types of memory, primary memory and secondary memory. So here, secondary memory will be outside the primary memory. So here, all the informations will be stored in the secondary memory. And here, whenever during the processing or during the processing system, the information or data will be called from secondary memory into primary memory for processing. So that is the concept. So what is a virtual memory? It is a storage allocation scheme in which the secondary memory can be addressed as though it were a part of main memory. So this is the concept of virtual memory. And here the addresses a program may use a reference memory, or distinguish it from the addresses the memory system uses to identify physical storage sites, and program generated addresses or translate it automatically into the corresponding machine addresses. So here the concept of address, the address of the memory location. Here the CPU is going to address the data from the computer memory by referring the memory address. So in that way, here we can talk about there are two types of memory addresses. One is logical address, second one is physical address. So the data will be stored in the computer memory in secondary memory with respect to the physical address of the data. But here, when you talk about virtual memory, see, it's going to create, or we are going to assume another type of memory. There's called a logical memory. So here, it is virtual memory. So the data will be stored in the concept of virtual memory with the logical address. So the logical, during processing, the logical address of a data will be mapped with the physical address of the memory, secondary memory devices. See, that is the concept of memory address in virtual memory. Now look at the diagram here. So by looking at this, we can understand few concepts here. See, first of all, physical address, we know that is secondary memory devices. So secondary memory devices is the main memory, physical address, and this is, I'm talking about virtual memory. And this is your CPU, and again CPU, and these are called frames. So the concept here is, this is the main memory of a computer system, and here, so this is virtual memory. So this is virtual memory with respect to secondary memory devices. So here, whenever the CPU, if you look at this diagram here, the CPU, it looks for a particular information with respect to frame. See, what are frames? Here, the main memory will be divided into number of frames of fixed length, that is called paging. So another concept we are learning here is paging. So what is a paging? Here paging is nothing but the main memory of a computer system will be divided into number of pages, and each pages will be having fixed length of frames. So here these are the frames. So here F1, for example, 0, 1, 2, 3, these are the different frame numbers. And these are all the physical address, for example. So here, in this example, this is called virtual memory. This virtual memory, the data will be like this. This is, for example, P1. P1 is the one process, and here P2 is the second process, and P3 is the third process. And each process will be divided into number of frames, a number of pages. We can say page 0, page 1, 2, 3. Similarly, page 0, 1, 2, 3 of process P2, 0, 1, 2, 3 pages of process P3. So, whenever this particular, whenever that CPU would like to process the data, it requests for particular pages from the secondary memory devices. So, from the secondary memory devices is going to talk about virtual memory. So here the secondary memory will be, the data will be in the secondary memory, will be accessed through virtual memory. So virtual memory is going to increase the capacity of your secondary memory. So that is the concept of virtual memory. So whenever the CPU requests for a particular page from secondary memory devices, it will be accessed through this virtual memory. See, for example, here this is called roll in or swap in, and this roll out or swap out. See, this is called swapping. So here we are learning the command called page fault, servicing the page, and swapping the page. What is the concept here? Here, what is the meaning of page fault? See, suppose in the case of main memory, so the CPU is looks for some of the pages of, for example, page 2 of process 1. In that way, if the same page is not available in the computer main memory, then actually the particular page has to be loaded from the secondary memory devices through virtual memory. That is the concept of swap in. So the data moving from secondary memory devices into the main memory for processing as per the requirement from the CPU. That is called swapping in. So suppose in another example, what is swap out or roll out? So here, suppose the if in the particular main memory, if there are no enough frames or no enough space in the main memory for the process, for any pages of any process, in that case, the particular pages or the pages which have been not used for a long time, those pages will be moved back to the main memory through virtual memory, that is called rollout or swap out. So this is the concept of swapping. So what is the concept of swapping? Moving a pages from secondary memory into the main memory and vice versa for processing, that is called swapping. So what is the page fault here? Suppose any pages request from the CPU, if that page is not available in the main memory of the system, and the same page has to be called from the secondary memory into the main memory. Okay, so that is called swapping. Suppose if the particular page is not available in the main memory, then it is called as page fault. And next one is called servicing the page. What is servicing the page? Here, suppose if page fault occurs, means the particular page is not available in the main memory of the system, then we have to call the particular page from the secondary memory devices into the main memory for processing, that is called servicing the page. See, these are the concept, and all these will take place in the inside the virtual memory. It is a logical address of physical memory, and it will be mapped with the physical address of the secondary memory devices. This is the concept of virtual memory. Now, it is a technique, means virtual memory is a technique implemented using both hardware and software. It maps the memory address by the program called virtual addresses into the physical address in the computer system. That's what I've told you in my previous slide. This is a technique. Next one is look at paging. So next concept we are talking about is paging. What is a paging here? So as I told you, the main memory, this is main memory of computer system, will be divided into number of pages, and each page will be having fixed number of frames. So for example, suppose this is the main memory of the system. So in main memory, it is divided into number of pages, and each page will be having number of frames. For example, see, this is the process 1. The process 1 will be having 1, 2, there are 4 pages, and process 3, there are again 4 pages, and again the process P2 will be having 4 pages, and here there are 4 pages. So here each process will be divided into number of pages, and number of pages in turn it will be having a collection of fixed number of frames. So in that concept, suppose this is the main memory, so this will be divided into number of pages. So this is called paging. So I repeat once again. See, what is a paging? Paging is nothing but the each and every process will be having it is divided into number of pages, and each frame will be divided into number of frames within the of fixed length. That is called a paging. So this is an example here. Main memory, and each there are number of processes will be divided into number of frames, and that will be allocated inside the main memory system. This is the concept of paging. In the next slide, we will see what is page table. Another concept is page table. The page table, it is nothing but it consists of, or it contains the information about the pages and the physical address of the memory. For example, see, this is the page table. In the page table, for example, page 1, and it is a page frame, and this is the physical address. So the page table is a concept where each and every pages it stores the information of the page address, the logical memory, and the page table for this is the number of frames, and this is the physical address. So this is page 1. For example, page 1, frame number 2. So here in page 1 is in page number 2. Similarly, page 2, if you look into that, page 2 in frame number 6. If you look at 6 here, so this is page 2. So this is the nothing but your paging concept or page table. So page table is consists of the physical address of the pages with the frame number. That is page table. Next concept is demand paging. What is demand paging? So here the definition is that the process of loading the page into memory on demand. Means whenever the page fault occurs is known as demand paging. So what's the meaning of page fault? As I told you in my previous slide, so whenever the CPU it looks for a particular pages from the main memory, if that particular page is not available in the page memory, so then it is called as page fault. And if the particular page is not available, then it has to get the page, or we have to call the required page by the CPU from the secondary memory devices for processing. That is called servicing the page. It's called page servicing. So here this is called page fault. And what is a demand paging here? See, whenever page fault occurs, means a particular page requested by CPU is not available in the computer memory or in the main memory, it has to call from the secondary memory. Now, that is the meaning of servicing the page. Whenever the CPU requests the page, then only is going for demanding the page. Then only is going to take the data or the pages from secondary memory devices. For example, here in this example, this is a main memory and this is secondary memory devices. So again, what is the paging here? Main memory, we have page 1, A, B, C, D and E, F, G. This is page 2. In page 2, there are 3 frames with 3 data, and again, in the secondary memory, again page 1, these are the P2, and this is another page 3 information. So in this example, now in the main memory, if the CPU asks for any data of A of page 1, in that case it is available here, then there is no question of page fault. So directly it accesses the data and process it. Similarly for A, B, C, D and again E, F, G, same thing will be available here. Suppose in this case, suppose if the CPU requests for any page of, suppose this is page 3 and here frame 1H, suppose the CPU it requests for frame 1 of page 1 of process 3. In that case, the particular page is not available in this main memory, then the situation is called page fault. So that is the concept of page fault. Then immediately, as for this is at this stage is called demanding the page. Now the CPU demand the page the page 0 of process 3. Now we have to load this from here to main memory. But at this stage, main memory, there are no space or there are no frames here. In that way, we have to push these process back to this secondary memory devices. So this is called swap out. When we have to go for swap out, if no space for any other page, new pages into the main memory, then the existing pages which we are not using for some time, these pages we have to move back to the secondary memory devices. This is the concept of swap out. So again, this is swap out, and again we have to bring this. This is, for example, this is page 0 of process 3. It has to bring back to this position after it is swapping out. So this is the concept of swapping. This is called swapping, swapping in and swapping out. So once it is these data or pages moved back to the memory and these will be empty, again we have to bring back the new pages from another process into the main memory for the processing as and when it requires for the process or CPU. If the CPU doesn't make any request, then we need not to go for swapping again. So only the swapping takes place only whenever the CPU requires a particular page for processing or request for processing. That is the concept of demand paging. And swapping will not take place before the demand paging or maybe even after the demand paging. So only when the CPU requests for a particular page, then only it happens. That is, demand paging will take place. So this is the concept of demand paging. Loading the data from the secondary memory into the main memory for processing as per the request from the CPU. This is the concept of demand page. Now, again, another definition, the process of loading the page into memory on demand. Only whenever it's required, it is called demand paging. It includes following steps. As we have seen, they explained in the thing. Same thing here. CPU tries to refer a page. If the current is not available, it has to generate the interrupt, indicating that memory access fault. That is nothing but page fault. Then this OS puts the interrupt process in a blocking state. For the execution of processed OS must be bring the required page into the memory. So this is swap in and swap out. Next, OS will search for a required page in the logical address space, that is in the virtual memory. Then the required page will be brought from logical address space to physical address space. See, that is what I'm talking about virtual memory or swapping in. That is the meaning of the page replacement algorithm used for this concept. So here, as we have seen in the previous example here, I have told you that the particular page will be bring back to the main memory for processing. So this is another concept called page replacement, and this is called page replacement, and the page replacement takes place based on its algorithm. This is by page replacement algorithm. The page table will be updated accordingly. So I told you in my previous slide what is a page table. See, this is the page table. So as and when the page replacement takes place, occurs, accordingly the page table will be updated. It consists of page number, logical memory with the page detail, the frame number and particular physical memory. So this is the page table. Page table will be updated accordingly. The signal will be sent to CPU to continue the program execution and it will place the process back into the ready state. And we know that every process will be having its different state, like a new, ready, running, and so on. Similarly, once everything is ready, so here the state, it will the process back into the ready state so that it can be executed by the CPU. Hence, whenever the page fault occurs, I told you what is a page fault. These steps are followed by the operating system and required page is brought into the memory through swapping. That is called paging, page fault, servicing the page, and swapping. This is about demand paging. Next one is, look, say what is the advantage of this. So here more processes may be maintained in the main memory. So because what is virtual memory? Virtual memory is it increase the capacity of the main memory or secondary memory. That is the advantage of virtual memory. So that more number of processes can be maintained in a virtual memory. That is the advantage of this demand paging. Now, process may be larger than all of the main memory, so it allows greater multi-programming levels by using less available memory for each process. So this is nothing but the concept of demanding page. So it is possible to have more number of pages in the main memory for processing, even though the space is very less. So the concept of virtual memory, it is going to increase the space of main memory through virtual memory for processing. So these are the advantages. Now let us see drawbacks. It's it can slow down the system performance as the data need to be constantly transferred between the physical memory and the hard disk. So it means swapping. Means the drawback is that it slow down the process because of swapping. I mean roll in or roll out or swapping in or swap out. Then it increases the risk of data loss or data correction, and it increases the complexity of the memory or memory management system. See, these are all the drawbacks or disadvantages of demand paging. Next one is page fault service time. I told you already the definition of page fault and page fault service. So the time taken to service the page fault is called page fault service time. Means the page fault service time, it includes the time taken to bring the required page to the CPU for processing. It is from the secondary memory devices. So this is called page fault service time. Next concept is swapping. As already have explained this, it is a process of process out, means removing all of its pages from the memory or making them so that they will be removed by the normal page replacement process. Swapping is the process of moving the pages from secondary memory into main memory pages and moving the pages from main memory into secondary memory devices. That's the concept of swapping. So at some time later, the system swaps back the process from secondary memory into the main memory and resume processing. Next one is when a process is busy swapping pages in and out of the situation is called trashing. See, another drawback of this, this is called trashing. What is a trashing? Now we know what is swapping. It is moving in data from secondary memory into main memory and vice versa. During that time, the chances of the condition is called trashing. Now let us see this is a diagram for swapping user space and secondary memory devices, and here process 1 and process 2, and again, and here we are swapping out the pages which was available in the main memory system. We are moving back to secondary memory system, is called swap out, and we are bringing or we are getting the process from secondary memory devices into user space for processing. This is the concept of swapping. Next definition is called thrashing. So we have told you in the previous slide. So at any given time, only a few pages of any process are in the main memory, and therefore more processes can be maintained in the main memory. This is, we know that. So any process to be processed it should be in the main memory. So it can have number of pages. So at any point of time, we cannot have all the process or all the pages of different processes into the main memory for processing. And furthermore, time is saved because unused pages are not swapped in and out of the memory. And here, whatever the pages we have not utilized for a long time, that has to be swapped out from the main memory for the efficient usage of computer time or CPU time. Now, in the steady state, practically all of the main memory will be occupied with the process pages, so that the processor and OS have direct access as many processes as possible. Thus, when OS brings one page in, it must throw another page out. See, this is a concept. Normally, whenever any process to be processed in CPU, it has to be in the main memory. So, if you talk about multi-processor operating system, there are more than one process to be executed simultaneously. At that time, it is not physically or in practically, it is not possible to bring all the pages of all the process into memory for processing. So in that case, during that situation, actually the memory or the CPU, which has to swap out the pages from the main memory, and we have to swap in the new pages into the main memory for processing. Next one is, what are the causes of thrashing? So those condition is called thrashing. And here, what are the causes for thrashing? High degree of multi-programming. And we just have told you about multi-processing operating system. Same thing, if number of processes keeps on increasing in the memory, the number of frames allocated to each process will be decreased, so that fewer frames will be available for each process. So as you know that each process will be having number of pages, and number of pages will be divided into equal number of frames of fixed length or fixed size. So accordingly, so due to this, page fault will occur more frequently, and more CPU time will be wasted in swapping in and swapping out of the pages, and utilization will keep on decreasing. So this condition is called thrashing. I mean, the swapping in and swapping out of pages for processing continuously for long time, then the situation is called thrashing. So one of the reason is this is the reason is that in multi-programming or in multi-process operating system, one of the cause of thrashing. Next one is another, look at the example here. For example, let free frames 400. Assume that there are 400 frames in the main memory. In case 1, number of processes is 100. Then each process will get 4 frames. Obviously, there are 400 frames and there are 100 processes. So 100 process here will get 4 frames for processing. Now you take second example or case 2. Here, number of processes is 400. Each process will get only 1 frame. That is obviously here, number of frames are more, number of processes are less. But here, number of processes is 400 and number of frames are 400. Obviously, each process will get 1 frame for processing. Next one is case 2 is a condition of thrashing. So this is the condition of thrashing. This is one of the reason for thrashing. Next one is, another reason is lack of frames. Same what you have seen in the previous slide. If a process has fewer frames, then fewer pages of that process will be able to reside in the memory, and hence more frequent swapping in and swapping out will be required. Obviously, if there are less number of frames and more number of processes, obviously there will be a frequent swapping will take place, and this may lead to thrashing. This is another cause of thrashing, and hence the sufficient amount of frames must be allocated to each process in order to prevent thrashing. How to avoid thrashing? This is by allocating equal number of or enough number of frames for particular process for processing. Next one is frame allocation. As we have seen in the previous slide, see here, each process or each pages will be allotted enough number of frames for processing to avoid thrashing. So here, what is frame allocation? Here, number of frames allocated to each process is either static or dynamic. There are two methods of allocation of frames. One is static and one is dynamic. In static allocation, number of frames allocation to a process is fixed. And in dynamic allocation, the number of frames allocated to processes changes, or it keeps changes as per the requirement. So there are two methods of allocation of frames for a process. Next concept is paging policies. Now we know what is a paging now, and we have learned what is page fault and demand paging. Now let us see what is paging policy. Here first one is fetch policy. What is a fetch policy? It decides when a page should be loaded into the memory. We have seen the definition, that is nothing but any pages from secondary memory, we have to bring it to the main memory for processing, that is fetching policy, or to fetch the pages from the secondary memory devices. Second one is replacement. What is replacement policy? It decides which page in memory should be replaced. As we have seen in the beginning of the slide, suppose if there are no enough frames or pages in the main memory for processing, then the old pages which were there in the memory, which has to be moved back, we say swapped out to the main memory, so that we can have enough space to bring the new pages from the secondary memory into the main memory for processing. That is called replacement. Again, it has to be taken by following the replacement algorithm. Next concept is placement policy. It decides where in memory should page be loaded. See, these are all nothing but different page policies to be followed with respect to paging policies. Dear students, so far in this session, we have discussed about the concept of virtual memory, and again with respect to paging and demand paging, page fault, page service time, swapping, and thrashing. In the next session, we are going to discuss about the page replacement algorithm. Thank you very much.